Hi and welcome everyone to this lesson in our course for wind turbines. In this lesson, we are going to discuss the wind turbine generator characteristics. So we would like to see how does the power or how does we generate electrical power from our generator, okay, depending on the speed of the wind. So as you can see, this figure representing the relation between the power generated by our wind generator with respect to the velocity of wind. So as you can see, this is the power available in the wind, and this is the amount of power absorbed by the generator. Of course, we cannot absorb all of the power inside the wind since we have the bits limit or the 59% efficiency. So our curve here, which is the power generated with respect to the velocity of wind, is divided into several regions. The first region is that here from zero power, and here we have zero power, starting from zero velocity to V cut in. This region, inside this region, the generator does not produce any electrical power. Okay, until the available power in the wind exceeds the power needed to overcome the windage and friction losses in the whole system. So in the beginning, when the speed of the wind is low, less than the V cut in, we cannot produce any electrical power. In this region, we cannot produce any power since the speed of the wind is very low and they are not enough to overcome the friction and windage losses, and of course it cannot start our wind turbine. Starting from V cut in, which is the speed at which our generator will start producing electrical power, this speed is called the V cut in or the cut in speed. This speed is the speed at which we start generating electricity. Now, starting from here, from this velocity of wind, V cut in, as this speed increases, the speed of wind increases, we or our generated power starts to increase, keeps increasing till reaching the rated power. Okay, so as the wind turbine speed increases due to the presence of more speed of our wind, the power output of the generator increases until the generator produces its rated power. So at V rated, the velocity of wind at which our power will be equal to the rated power. Okay, this rated power depends on the generator installed. For example, if we have a 100 kilowatt generator, it means that we cannot produce more than 100 kilowatt, whatever the speed of the wind. Okay, now this speed at which we produce the rated power is called the V rated. When the speed starting from V rated, when the speed of the wind starts to increase, keeps increasing, we still produce the maximum power or the rated power. Okay, so we have a constant power generated. Whatever the speed of the wind increases beyond the V rated, we still produce maximum power, which is the rated power of the generator. Until we reach a certain speed, V cut off, this speed of the wind, which can produce very large mechanical forces on our wind turbine, and they can lead to the damage of our wind turbines. So starting from V cut off, this is a speed at which the wind turbine will rotate at a very dangerous high speed, which can lead to the destruction of our wind turbine. So in this case, we start, the wind turbine is filled and the generator is stopped. And what I mean by filled, it means that we are moving our wind turbine away from the wind direction in order to prevent its damage or breakdown. And this speed at which we start shutting off our wind turbine is called the cut-off speed. This speed is important because it helps us to protect our wind turbine against damage. So as you can see, this curve representing the generator characteristics or the power generated with respect to the wind speed. Now, here is an important note which we can notice in this curve. You can see that between V cut in and V rated, the relation between the velocity of air or velocity of wind with the power generated, as you remember, is that we said before that the power produced by the turbine is equal to half multiplied by area of the turbine multiplied by the density of air or wind multiplied by the velocity of the wind cube. So as you can see, this relation, the relation between power and the velocity of wind, should be a cubic relation, right? However, this is in theoretical. Okay, theoretically, the relation or the increase in power should be a cubic relation. Okay. However, when we design our wind turbine, we can, depending with the design of this, we can make this relation, instead of being cubic, we can make it linear, we can make it quadratic equation, we could make it a cubic equation such as we have now, or we can make it even higher powers. Now this depends on the design of the turbine. Okay, depends on the wind turbines which are available inside the market. Now as you can see, since we can control this relation, you will find that the power produced by our wind turbine is equal to the rated power multiplied by V to the power n. N is the relation here. Is it linear? Is it cubic? Is it quadratic? So it will be V to the power n, the velocity at any time we would like. If we would like here, whatever it is, the velocity at which we would like to get the power generated, to the power n minus V cut in to the power n, the cut in velocity, divided by V velocity at which the rated power occurs, V rated, to the power n minus VCI to the power n. Of course, the cut in, the V rated, V cut off, this depends on the design of the wind turbine itself. Okay. So for example, if we have a linear relation, then n in this equation will be equal to 1. Now let's have a quick example on understanding this. We have the relation B equal BR, and as you can see, this is the same equation as before. Now we would like to have an example of a wind turbine. Let's say, for example, we have a 2 megawatt wind turbine. So the P rated, the rated power is 2 megawatt. This is the maximum power which we can generate, and has a cut-in rated cut-out velocity 3.5, 13.5, 25 meters. Now again, what does 3.5 meters represent? The cut-in is the velocity here at which we start generating our electrical power. The rated speed is 13.5 is the speed at which we start generating the maximum power, okay, or the rated power. 25 meters per second is the cut-out velocity. 25 meter is the cut-out velocity, or after which we shut down our wind turbine. So VR is equal to 13.5, VCI is 3.5, and as you can see here, we can be rated 2 megawatt multiplied by 3.5 cube, 13.5 cube minus 3.5 cube. So for example, if I would like to find the power generated at 10, for example, at 10 meter per second, then we will substitute with V equal to 10 meter per second. So as you can see, from 13.5 to 25 meters, from here to here, we will generate the maximum rated power of 2 megawatt. When the velocity becomes greater than 25, which is the cut-out velocity, the turbine produces no power as it is shut down. So in this lesson, we discussed the generator characteristics of the wind turbine, and now we understand the effect of velocity on the generated power. In the next lesson, we will have an example on this in order to understand more practical what happens. Okay?